Welcome back, and we're jumping right into it. So if you did not watch the last video where we did a crash course on classes, I recommend that you go back and watch that. If you didn't get it, maybe do some additional research before you continue, because you need to understand classes before we continue on. You don't need to understand how to write one, you just need to understand how to use them. So today we're talking about the pathlib module in Python. This module provides you with various classes that help you represent the file system paths with semantics appropriate for different operating systems. It's really useful, and the best part, this module actually comes in the standard utilities, so you don't even have to install it. Now, inside of this module, there is a class, right? So we talked about classes before, and this class that we're going to use is called path, and we're going to do everything in the pathlib module through the path class. Okay, the path class gives us all the instance methods and class methods that we're going to need. Okay, so in order to use pathlib, you have to import it. And because, like I said, it's part of the standard library, you don't have to install it. Sometimes when you come across libraries, you're going to have to install them, or modules. I call them libraries. Just depends on what programming language you're talking about. Technically in Python, it's a module. But you import pathlib, and if you import pathlib, you can use the class by typing out pathlib and putting a period and then typing path. So you're telling Python, hey, I want to use this path class in the pathlib module. And this looks pretty familiar to the date constructor and the string constructor that we looked at before, right? So we've got our parentheses, and we're passing in a value of a path. So a path in Python, well, actually not in Python, but on your computer, a path is just a directory. It's a location. It's an address of files and folders on your system. Okay, so when you open up on Windows, when you open File Explorer, up at the top of File Explorer, you have your path, and it shows you where you are. You know, are you in your downloads folder? Are you in your desktop? Technically, your desktop is a folder as well. So you can navigate around and see all of your different folders. And when you're creating a path object, an instance of the path class, you have to pass in a path that you want to set. So in this case, I have a hypothetical path, right? On Windows, which is what I'm going to talk about for the remainder of this discussion on working with files. But that doesn't mean you can't follow along if you're on Linux or Mac. Your paths are just different. You use forward slashes, Windows uses backslashes. But you'll see in a minute that actually when we're talking about path, we can use forward slashes as well on Windows, which is very nice. But we have a hypothetical path here of C user's username. Now this is a standard convention on Windows. So whatever your username is on your machine, you will have a path called C user's username. Now the first thing you probably notice is there's some backslashes, and there's too many, right? You should only have one between each word. Well, in Python, if you don't use a raw string, you have to escape that backslash. Otherwise, Python gets confused. So you have to, because the backslash is how you escape things in Python, right? So you can't just throw it in a string or it thinks you're trying to escape a U, for example, right here. So you have to escape the escape character. and it gets a little messy. So we're going to see how to fix that in a minute. But first, typing out pathlib.path is kind of annoying, right? That's a long thing to type out. So what we can actually do is type from pathlib. So from the pathlib module, import the path class. So we're being very explicit. And by doing this, we're able to just type path. It's very nice, very nice. So we can just type path class out now and use it. So now we're creating a path object, an instance of the path class, and assigning it to the myPath variable. Now, like I was saying, you can use raw strings. So if you put that R in front of the string, then it's a raw string. And Python knows, hey, there's nothing going on inside the string that I need to try to interpret. So whatever character you put in there, I'm going to think is just a regular character. And that way you don't have to type out extra backslash. You can actually join multiple strings together to create a path by separating them with a comma. So right here, if I run this, it's not going to output anything, but well, actually I need to run this to import path, and then I can run this, but it's not going to print anything yet. But we'll show you here in a minute how that can, it'll add in the path character for you. It adds in this backslash. Okay, and if you're on Windows OS, what I recommend that you actually do is use forward slashes when you're defining a path. It just makes it better, and you're going to see why. It makes it make more sense because right here, so if you do the forward slashes, first of all, you don't need to use a raw string because the forward slash is not an escape character. It's just a regular character. And yeah, I mean, you don't have to do a raw string. You don't have to double escape. So forward slash is better for defining a path. It's just nicer. Also, when you want to, once you have your path object, like we created one called C users, so it's representing the C users path, we can add to that path just like you would with two strings. You can concatenate or add two strings with the plus sign, right? You can actually add two different paths together with the forward slash. Little interesting, right? So we're not dividing on the path object. It interprets a forward slash as, hey, you want to add on to the path. So that would create C users, C forward slash users forward slash username, which on Windows would turn into C backslash users backslash username. I just didn't say the colon, but yeah, so you can add using the forward slash. Now let's talk about some of the class methods. You can see right here what would happen, right? It adds those together for you. Pretty nice. So the path class method, right? So the class method, like we talked about in a previous video, is a method that is called on the class, not on an instance of the class. So you can use the path class and call this method CWD. That stands for current working directory. And if you use this, now this is a little confusing because it turns out that Google Colab runs on Linux, but I wanted to show you Windows because most of you are on Windows. But when you print out what's the current working directory, if you try this on your own machine, you'll see that it prints out where the script is running. It's the current working directory. It's where you are in the script when the script runs. Very useful because any of the things that you do with modifying files and creating files and moving files, you need to know where you are, right? You need to know what's in the directory you're in as well. So we're going to get to that in a minute, but also another class method is path.home. This returns the home directory based on where you are, what OS you're on. So if you're on Windows, your home directory is always going to be C users and your username. If you're on Mac, your home will always be /users /your username. Linux, home, username, same idea. The home directory is a good place to know about because usually when you're running a script, you will have access to write in your home. If you don't have admin rights, you might not be able to write everywhere on the system. So using path.home as your baseline of like, where can I go to start creating files? Well, start in the home because you know you're going to have access to write there, typically. If you don't, you're in a weird situation. So path.home is good to know. So what are some path instance methods that we can call? So when we create a path object, we can call some methods on that object. So here I create a path object and I wanted to show you, I don't have to assign it to a variable. I can just create the object by calling the path method. That will create and return an object. Now, what am I doing with it? Well, I call a instance method on it, and I call a very interesting one, mkdir, make directory. And just to reiterate, a directory is just a folder, but it's a holdover from old times. In computer languages, we always talk about folders as directories. So just correlate those two in your brain and you'll be good to go. Directory equals folder. So what we're doing is inside of the C user's student username, we're creating a folder called homework. That's what this command will do. It's going to make the directory explained here at the very end of the path. Pretty neat. And here's another example just to show you. I could assign the path object to a variable called p and then call my instance method. It doesn't matter. Either one, you can create a variable or not, doesn't matter. What matters is that you have a path object to call on. Now we have the exists function. This returns true if the path exists and returns false if it doesn't. This is pretty useful because before you create a path, you probably should check if it already exists. If you don't, you'll run into an error. So, because Python's going to try to create the directory and say, oh, I tried to create that, but it already exists. So you define your path, right? Let's say you want to create a homework folder. And before you create it, you should ask, hey, if the directory does not exist, so if not p exists, then we're basically saying if the directory is not there, if the folder's not there, then make it, right? Pretty cool. Another instance method that we have is isdir. This returns true if the path exists and is a directory. So instead of just asking, does this exist? Well, it turns out exists could be true if it's a file or a folder. So you might want to be a little bit more explicit, right? It would be better if you're going to create a directory to check if it exists as a directory. Maybe there is a file under the C user's student folder called homework, right? Well, if I ask if it exists, it's going to return true, but I'm trying to create a folder, and you can have a folder and a file with the same name. So using isdir, we'll just do the same thing, but now we're going to check and see, does it exist and is it a directory? Is it a folder? IsFile does the same thing, except this time now we're checking, is it a file? We want to know, does it exist and is it a file? And then if it doesn't exist, so if not isFile, then we create a file, which we're going to cover later. Now this last one, I think this is the last one, the glob pattern. Now this one probably looks a little intimidating at first. First of all, it's named glob, which is not exactly the most endearing name, but it's very powerful and useful. So glob patterns are a simplified form of regular expressions, which we learned about very recently, right? And now you're seeing why the regular expressions were important. So you can use the glob method to search for specific files in your directory, which is awesome. Because what you can do is you can say, hey, I want to create a path, C user's student, and assign it to this P variable. Then what I want you to do is use the glob method right here. So this is the way you use it. You call p.glob and you pass in your pattern, just like regular expressions. What does the star stand for? It stands for anything, right? So in a glob pattern, what you're saying is match everything, okay? And then we wrap it in a list constructor. So we're saying, hey, whatever this p.glob returns, turn it into a list object. Turns out what this will do for you is return every file or folder found in the student folder or the student directory. Pretty neat. So you can see everything that's in there in your code. You can see everything that's in the student directory. Now we can get more powerful with it though. We can add in extra text and we can say star, so anything that ends with .txt. Now keep in mind that this is a simplified version of regular expressions, so some of the syntax is not exactly the same, but some of it is. It's a simplified version. So the dot actually just stands for dot in this case. But what we're saying is any file, so it can have any name and it ends in .txt, I want all those. And it'll only list out the files in the student folder that end in .txt. So the file extension is .txt. So you can get all your text files only and see those and cut out all the noise. So you can also add in there's one more thing you can do. You can add in a question mark to represent one character that could be anything. We call the star, the asterisk, a wild card. And the asterisk represents any number, in this case, any number of any character. So it could be 15 characters long, any characters doesn't matter. The question mark is a wild card for only one character. You can have any character there, but it can only be one more. So this is a way where you could look for any file in the folder that starts with the word homework, has any other character, like a 1, 2, 3, 4, 5, Z, whatever, .txt, and find only those. So you can use your creativity to come up with a few ideas of how you could use this to really use a fine-tooth comb and look through a directory and find certain files you're looking for. Now, the last thing we want to talk about is path object properties. So we've talked about instance methods, class methods, and there's one more thing about classes that's really cool. Classes can sometimes have properties that you can access. Well, when you access a property, you don't need to provide parentheses. You're not calling a function at all. You're accessing a variable. But when a variable is attached to a class or the instance of a class, we call it a property. So our instance of the path class here, where we're referencing the C users student directory, has several properties that we can look at. It has the anchor, parent, name, stem, suffix, and drive properties. Each of these represents different parts of the file path. So if we run this, oh, well, it didn't print any of it. Cool. Well, anyways, I think it's because I didn't run some of the other ones above, but it doesn't matter. We can talk about it. The anchor is the root of the file system. So in this case, it would be C, C:\\, actually. The parent is the folder that contains the file. In this case, the parent is users because it's the parent of this folder. The name is the full file name. So in this case, we actually don't have a name because we don't have a file name. So I actually want to run this because this would be better. Let me come back up here. I just need to import, make sure class is imported. Yeah, run that, come back down. And try to run this again. I think I have to print, unfortunately. Let's see if I print the anchor. And nothing. Okay, well, I tried. In any case, these are the properties that you can use. I'm having a little bit of technical difficulties, but you can access these properties on any path object, and they're pretty useful. So I recommend that you use these when you need to. It can be helpful because when you get a file, for example, and you're trying to work with a file, maybe you just want the file name. So you don't want all the extra junk on the front of it talking about the directory that it's in. So when you have a path pointing to a file name, just use .name on that object and you'll get just the file name. If you use the stem, it's the file name without the extension. So remember that every file has an extension telling you, sorry about that, tells you about what kind of file it is. So a .txt tells you that it's a text file, right? Sometimes you don't want to know .txt, you just want to know the name of the file. That's called the stem. The suffix is the file extension, so .txt. And only on Windows you have this .drive, and it's the single letter that denotes the physical hard drive or the storage device. So on Windows, C, for example, is your main physical hard drive. And when you plug in a USB, it might be E or D or whatever. So that's what drive is. And that covers all of the pathlib module. In the next video, we're going to take a look at the OS module. I look forward to seeing you in that one as well. Thanks.